Here is another study carried out in America, right, available in this website, wherein they try to relate the GRACE derived water balance data, right, using which they had come out with the, but that means what GRACE gives? GRACE gives measures the changes in terrestrial water storage, right. Terrestrial water storage here, at this particular site there are two aquifers, as you can see in this cross section, right. One is the top layer is unconfined aquifer, right, with a water table somewhere here. Then there is a impermeable layer or less permeable layer. Beneath that we have a confined aquifer. So, we have a unconfined aquifer at the top and a confined aquifer at the bottom, right. Over there, right, due to overuse of groundwater from confined aquifer as well as from unconfined aquifer, there is a little bit of compaction that is taking place in this confining layer, that is leading to land subsidence, right. That is leading to land subsidence. What is land subsidence? Land subsidence is a vertical downward movement of the earth surface. Okay. So, earth surface deformation can be also sensed from the satellites, which are radar satellites. These satellites passes radar waves. These radar waves comes and meets the ground surface and gets reflected back, right. Due to which we will know the time of travel of these radar waves from the source to the surface, ground surface, and then it gets back to the receiver. From the time it takes, we will be able to know the location at which it got reflected or backscattered. Right. Here too, we will repeat the measurement on a monthly basis. So, when you make the measurement on monthly basis, we will know whether the point from where it got backscattered is at the same location or not, isn't it? So, today if it takes 10 milliseconds, after a month if it takes 15 million seconds, what does it mean? Probably the land surface has gone down, right. So, in this study they had tried to compare the groundwater abstraction estimated from gravity data with the radar data to relate land subsidence with the groundwater abstraction, right. Right. So, here they had tried to come out with the GRACE data, right. This is the GRACE data indicating, right, what is the volumetric change in the groundwater pumping from unconfined, and this is from confined aquifer. Right. So, from unconfined aquifer as well as from unconfined aquifer, they have found out how there is a change in the groundwater usage. From where? From gravity measurements, right. From the gravity measurements we have understood what is happening, right. Then from the radar data, right, from radar data we try to understand how the ground surface is getting displaced. So, here you can see the scale, all the colors beyond this toward this side, especially all the yellow, red color indicates the land is going down, right. So, that means these are the regions where the land surface is slightly going down, right. So, this is the data with this kind of temporal resolution, right, almost monthly. Yeah, it is not monthly, yeah, November, December, then January, February, yeah, it is a monthly data. So, how? So, here there is a lot of land subsidence, here too lot of land subsidence, right. This color, that is yellow color, right. So, they try to compare how groundwater pumping is related to land subsidence. For example, here, right, all these colors indicate gravity value is going down. That means this particular region where gravity value is going down, indicating there is large amount of groundwater pumping from the lower aquifer. So, correspondingly, they try to correlate at this particular zone there is a land subsidence, right, everywhere, almost in all months. This particular zone there is a land subsidence. However, there is a slight variation in certain months that is attributed to the temporal variation in groundwater pumping, right, because groundwater pumping is very much necessary whenever there is not much of surface water available for irrigation purpose at this particular site, right. So, this study try to apply the GRACE data and also relate the GRACE data derived groundwater pumping with that of land subsidence. How did we derive about the land subsidence? Land subsidence also was determined by radar satellites, right. And here is another study in which this group of scientists from the Indian Institute of Technology, Indian School of Mines has carried out a study on the application of GRACE to understand change in groundwater storage over the entire India, right. So, here using the GRACE data, right, collected from the year 2003 to 2016, right. This was a recent publication, yeah, it came in 2020, right. They try to come out with change in the groundwater storage in two different time periods, that is pre-monsoon period, before most of especially southern India receives rains during monsoons. So, during October, November, December, September, October, November, December. So, they have taken up the summer time as pre-monsoon, right. So, this is how the pre-monsoon, the first diagram. This is the sketch showing how the groundwater storage has taken place during the pre-monsoon period, right. The change in groundwater storage is much higher in zones indicated in blue color. That means almost over the entire India except for the northeast near the Himalayan region, right. Himalayan region aquifers. Apart from that, everywhere there is a drastic change in the negative trend in the groundwater use storage, right. That means lot of water has been put into use. That how did we do this? We just compared the gravity data of summer time from 2003 to 2016. That means this shows the difference between 2016 and 2003. Similarly, here in the next diagram, we are looking into post-monsoon. So, here is the pre-monsoon, here is the post-monsoon. The gravity data is converted in terms of water height, equivalent water height, given the unit is in centimeters, right. In post-monsoon too, there is a huge, even after monsoon, not much of a recovery except for comparison between these two. Here there is in this part, in southern part, in Tamil Nadu part, there is some marginal benefit. From blue it has become slightly bluish green or green, right. So, this is the overall, right, overall groundwater storage change rate across India from 2003 to 2016, indicating, right, over the entire India there is a groundwater decline in groundwater storage compared to 2003. In 2016 there is a decline in groundwater storage. The authors have also interestingly carried out this study by comparing the hydrogeological map of India. Right. So, what is the relation between this as well as the hydrogeology of the India? Right. And in the same study, they had also focused on certain major urban regions of India. Right. They focused very much on these cities. Right. Here in the top diagram indicates the annual variation in the rainfall or precipitation. Right. What is the annual variation in precipitation? For example, if you take Mumbai, all the red bars indicate Mumbai, and Kolkata green, maybe Chennai is in blue color. Right. So, this is the annual variation in the rainfall. Why we are considering rainfall? When we are going to talk about groundwater storage, change in groundwater storage, the immediate question will be, what is the rainfall? Can we always say we are over pumping groundwater? No, we have to certainly compare with the water table can keep going down due to over pumping and also due to reduction in recharge. To indicate there is not much of a reduction in recharge, they are comparing the annual precipitation with the annual change in groundwater storage. Right. So, let us take for example, maybe Mumbai. In Mumbai, the rainfall is varying between somewhere here. Rainfall varies between this, not much of a big difference. I don't see in the red bar, more or less between this range. Now, let us have a look into the same red in groundwater. This the next diagram is groundwater storage, change in groundwater storage. Right, yearly change. Right. Let us look into red bar. So, red is here and it goes up and again it is up, here it is down. Right. So, not much of a problem in the case of Mumbai city as per the study. Let us take up Chennai. Right. Chennai is in blue. In Chennai rainfall there was lot of variation. Right. This is the lowest I could see and the highest in Chennai would have been sometime during, yeah, this is the highest. So, somewhere between this it varied. So, if you take Chennai, which is in blue color, always groundwater storage is on the negative side. Right. Overuse of groundwater. Similarly, let us have a look into Kolkata. Kolkata, the average rainfall is more or less the same, within this band. Right, where is the lowest? Yeah, so this is the lowest somewhere. Yeah, this is the lowest. So, this is the fluctuation in rainfall for Kolkata. Whereas, if you look at groundwater, right, initially it was on the positive side, but coming here, water table is keep going down in Kolkata. Large use of groundwater resources in Kolkata region. Over there, we also did a study to understand whether there is any deformation on the land surface using the same radar data. Right. Here we have used European Space Agency's satellites radar data. Right. So, as I had told you previously, what we are doing is the satellite sends radar waves goes back to the same satellite and received, and based on the time taken, we try to determine the expected distance of the location from where it got backscattered from the location of the satellite. Then during the next pass, this is time 1, during the subsequent pass, it again determines whether the elevation is the same or not. So, we need minimum of 2 data, right, at 2 different time periods to understand whether there was any change in the land surface between these 2 times. So, that is what we did for Kolkata city as a part of ISRO sponsored project, right. where we found out from the Central Groundwater Board data, the piezometric surface is going down as indicated by these researchers, right? You focus your attention to the green bars. Green bars are on the negative side and their length is also increasing, starting from somewhere according to their study, somewhere from 2008 it is going down. Here is the observed piezometric data, right? Somewhere from 2000 itself it has started going down. Piezometric surface is going down. In this region here, using the synthetic aperture radar data, right, we have come out with the subsidence velocity between the year 2003 and 2010. What do we mean by subsidence velocity? We had used periodical radar data between this period 2003 to 2010. Since we had periodic data, we could come out with what is the rate at which the land surface is going downwards between the two time periods, using which we came out with the subsidence velocity indicated in different colors in this map, right, in this interferogram, right. Here we can see all these colors indicate the land is going downwards, which are located somewhere here, red and yellow color, indicating that in this region land surface is going downwards. At what rate? Not very alarming, at the rate of about few millimeters per year, right, few millimeters per year. So, we wanted to know what is the reason for land subsidence. One reason is part of the region is backfilled, right, there can be some compaction. Apart from that, we wanted to also find out what is the likely reason. As we have seen here, the groundwater head is going down and we collected groundwater data from several wells located in this region and plotted the piezometric surface, right. The piezometric surface shown in white color here, all these white contours in this diagram indicate the piezometric surface. The one around the region where the land subsidence is predominant, you can see the piezometric surface is minus 13. So, as we move away from that region, the piezometric surface is at a much higher elevation. So, this also clearly points out the region from where we are pumping large amount of groundwater from a lower confined aquifer, over there the land is also subsiding, right. So, this is how I would like to correlate the GRACE data with the radar driven land subsidence data. Then we also did, as a part of another project funded by the Department of Science and Technology, we did a study in Chennai region using GRACE data, right. Using GRACE data, we wanted to find out what is the relation between the land use change in and around Chennai region, right. This is the more or less this is the urban part of Chennai region, right. And correspondingly, you can look at the geology of the region in this map. So, here is approximately the land, all the red color indicates urbanized region build up, and here what you see is the lithological information or the geological map of Chennai and its surroundings, and the grids which we see here, they are all the pixel size of GRACE data, right. So, this is a grid which is partly on the sea, partly on land. This is completely on land. So, we wanted to carry out a study to understand the water balance in Chennai by taking the data of grid 1, 2 and 3 and also 4. To understand what happens to the sea surface, we took this grid also, right. That means we can understand how the gravity, or very precisely how the acceleration due to gravity collectively varied in these grids. The variation in gravity has to be only due to, for example, monthly variation in acceleration due to gravity is to be related to change in terrestrial water mass, right. So, that was compared to know whether there is any major change in this region, and we also had observed groundwater level data from all these red dots maintained by the Water Resources Department of the state government. So, this data was also used by us to cross check the information which we could get from GRACE data. So, here is a comparison of time series derived from GRACE data of both groundwater as well as sea level in Chennai. So, what you see here, all the red line indicate groundwater and the blue is sea level, right. As usual, it is given in equivalent water height, right. Equivalent water height, it is given in with respect to time. With respect to time, we are seeing the equivalent water height. Here you can see, with regard to water table, it fluctuates annually responding to the monsoons, and sea level also is marginally varying, but we can also see a marginal kind of negative, or almost it shows more or less the same, right. A little bit of negative trend I could see, but let us focus our attention on groundwater level. So, groundwater level in this particular pixel is more or less going up and down. We do not see any major trend for this time period of 2000, from 2002 to 2016. It is a bit old data, right. And similarly, here for different grids, you can see what is happening. So, here with regard to the sea, some minor upward. Here with regard to water table, it goes up and down, right. Here, this is how we are able to compare how the water balance, not water balance, especially groundwater storage changes with respect to time in this particular pixel. Then here what we did, if you focus your attention to this particular diagram, here we are correlating the observed groundwater data collected from so many wells with the GRACE derived groundwater level data. So, this is the GRACE derived groundwater level. This is the groundwater level from the data collected from different agencies. So, there is a reasonable comparison. So, what does it indicate? The gravity help us to understand about the groundwater conditions in the region. So, here we are able to relate gravitational pull, how the Earth's gravity changes with respect to time is able to correlate very well with the groundwater level fluctuation, right. Here too, on this diagram, with respect to time, we are plotting the groundwater level derived from GRACE data, which is shown in blue, and red is groundwater level derived from the observed data, right. There is a reasonable comparison between the two, right. So, this indicates gravity data help us to understand about the change in the groundwater storage. And similarly, here is for another pixel in which we are comparing the GRACE derived groundwater level data right, and also green is in situ data, that is observed groundwater level data. Here is the change in the level of water in the sea, which we could get from a grid which is mostly occupied by the sea. So, here we can see a marginal rise in sea level, right. So, the gravity recovery and climate change experiment mission not only help us to understand the changes in groundwater storage using gravity data, but also we are able to understand how the climate change affects the sea level, can also be sensed from the satellite borne gravity measurements. Okay. And why? As the sea level rises, every centimeter rise will lead to increase in the gravitational pull. As the sea level rises, the satellite will come much closer to the surface, isn't it? Because the acceleration due to gravity will increase. So, this is how it also helps us to understand about the rise in the sea level, right. So, with this we have understood the gravity methods of investigation or exploration. We started with Newton's law of gravitation, then we had seen what are the reasons for large scale variation in the Earth's gravity, which is mainly due to the flattening of the Earth and also due to Earth's rotation. Then we had said the variation in gravity is also due to change in the density of the materials present below the surface of the Earth. That is what we are looking forward to understand. Then we had a look into different instruments, especially gravimeters, different types of gravimeters. We had a look and how gravimeters have to be calibrated. Then how the data is collected from the field, what are all the corrections or gravity reduction have to be done. Then we had seen very briefly about the interpretation, what is residual anomaly, how we can get the regional anomaly removed to arrive at the residual anomaly. We did not see elaborately, but it would have given you an idea of there are techniques, filtering techniques available to overcome the regional anomaly or eliminate the regional anomaly to arrive at the residual anomaly. Residual anomaly is the local anomaly, using which how we can decipher differently shaped bodies, how we can do arrive at the subsurface model by inverse modeling tool we had seen. Then we had seen some case studies. After that, we had also seen about the GRACE mission. Thank you very much.